Let's now shift to parallel circuits and find the equivalent resistance of a parallel circuit. Recall, a parallel circuit is when the current comes out of the battery and it has a choice to make. Some charges will go this way, some will go this way. You cannot draw just one loop and cover both resistors. Right? One loop would go like this. You're only hitting one resistor there. And if I try the other way, I only hit the other resistor. So that's what a parallel circuit is. Let's start with the current. You have a current I coming out of the battery. This is conventional current, flow of positive charges. And it comes up here, and the charges have a choice. Some will go here, some will go this way. But whatever charges enter, the same amount of charges must leave. That's called the conservation of charge. So the current through this resistance, I1, and the current through this resistor, I2, have to add up to equal I. So I will split. Some of it is I1, some is I2. They'll rejoin, and then back at the other side, you're back to having the full current I. So I equals I1 plus I2 by the conservation of charge. What happens to the voltage as it moves around the circuit? Current's coming this way. Each charge has a certain amount of potential energy U, right? Because U divided by Q is equal voltage. So what happens to the voltage in R1 and R2? Let's focus on what a battery does. A battery delivers energy, potential energy, to each charge, and that equals the voltage of the battery. So every charge that comes out of here has the same energy. The charges now can go one way or the other. So let's put an example. Let's say we have an 8-volt battery. That means on this side, the positive charges have 8 volts of energy per charge, and on this side they have none. All of their energy is transferred to the resistors or the wires. They heat up. It's thermal energy. The electrical energy of the charge goes into thermal energy of the resistor. So that means any charge that comes here has 8 volts per charge, and on this side it has to have 0. So we have 8 volts over here, 0 over here. Anybody connected to the negative terminal of a battery is defined as having 0 volts of energy per charge. So if I have a charge going this way, it starts at 8, goes down to 0. Here it starts at 8, goes down to 0. That means the voltage across R2 and R1 is the same, and it's exactly equal to the voltage supplied by the battery. So we have that V coming out of the battery equals V1 across resistor 1 and V2. The voltages are all equal. To find the equivalent resistance, we'll start with the current. This was due to the conservation of charge. I is equal to I1 plus I2 plus I3, where we have 3 resistors in parallel. We then substitute what I is equal to. Well, that's V over R. This V is the voltage from the battery, and this R, very soon, we're going to be called R equivalent. V1 over R1, V2 over R2, V3 over R3. The previous slide, we showed that the voltage out of the battery is the same across every resistor in parallel. So all the voltages are the same. So this V1 becomes V, this V2 becomes V, and this V3 becomes V. We have voltage in every one, cancel it out. So we cancel it, we factor the V first, and then we cancel it, and we get 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3. Now, when you solve these problems, a lot of people will do this part right, and then they'll say that the equivalent resistance is 1 over R1 plus 1 over R2 plus 1 over R3, but that's wrong. That's 1 over R equivalent. So when you're done adding the right side, make sure you flip the answer. Take the inverse of it. Very careful. Be very careful about that. Make sure you flip your answer at the end. Sorry I said it twice, but it's a pretty common mistake. Now, what if we were to add more resistors in parallel? What would happen to the resistance of the circuit? In series, the resistance would increase. Think about what happens here by looking at the math and maybe conceptually think about it, and then go to the next slide. Adding more resistors in parallel will decrease the equivalent resistance of the parallel circuit. Check the math out and you'll see that that's true. Conceptually, adding more resistors in parallel gives you more paths for the electrons to flow. They have more choices. Hence, for a given electric potential, more current will flow. If that's the case, so we have V equals IR, and then we want to find out what happens to the equivalent resistance if more current is flowing. Well, for a given voltage, if I have more current because I have more paths, denominator goes up, that means the resistance will decrease. So your equivalent resistance goes down. Another way to look at that is if there's one line going into the movie theater and you have a lot of people, you have 100 people online, it takes a while before they get through. There's a large resistance to those people getting into the movie theater. What if you now have 10 openings, 10 different lines they can go on? People will get through much quicker. So you have a greater current of people and you had a smaller resistance to them getting into the movie theater.